Okay, this is another video on the subject of complex numbers, and this is going to talk about solutions to quadratic equations that don't have real solutions, and also about conjugates and factors of quadratic equations without real solutions. So I've got a curve here, and it doesn't cut across the x-axis, and so from this, we can say that there are no real solutions, but there are two solutions, and those two solutions are complex numbers. Now here is the equation of the curve, and what I'm going to do with this is I'm just going to try and solve it using the quadratic equation solver, quadratic formula. So that has minus b, so that's going to give me 4, plus and minus b squared, that's minus 4 squared, of course is 16, minus 4 times a times c, so that's going to give me minus 4 times 5 is minus 20. Now before, when you were doing these sorts of questions, you would have come across this, let's divide it all by 2, and you would actually say, in here I've got a negative number. So that would be a problem, and then that's when you'd say, we can't solve this. But here now we've got negative 4, and we're trying to find the square root. What I'm going to do is I'm going to break that down and call it 4i. So I'm going to call it the square root of 4 times the square root of negative 1. And negative 1 is my I number. So this is 2i divided by 2. So all of this should all be x equals, of course. Let's make it absolutely correct. So when I get down to here, I'm going to do 2 divided by 2 to give me 2, plus the square root of 4, which is 2, I'm going to divide that by 2 to give me 1, and then negative 1 is I. So there's one solution, and the other solution is going to be the same thing, but with a negative. So 2, take away the square root of 4, 2, negative I. Now that's actually nice and neat, but more importantly, look at this. This is 2 plus I, and this is 2 negative I. And this is called the conjugate of this one. So if I have one number, such as x equals 2 plus I, by making the imaginary part a negative, we have the conjugate. And this will always happen for solutions of quadratic equations, or actually these are just solutions or roots. So one further thing that I want to show you is that I can actually make these two solutions into factorized form, and then I can actually multiply out to get back to where I started. So I'm going to need another page for this. So I've got x, and I say that's minus 2 plus I, and x minus 2, the conjugate x, minus 2 minus I. So this is it in factorized form. So this is like y equals. Now if I expand all this, I get x times x, which is x squared. Now I'm going to expand everything in the second bracket. So I have x times negative 2, which is going to give me negative 2x. I have x times negative I, which is going to give me positive 2xi. Then I'm going to multiply this bracket by x. It's a negative 2 times x, which is going to give me negative 2x. It's going to give me negative I times x, which is actually going to give me, sorry, I made a little mistake here. This isn't 2, this is x times I is xi. And here we've got x times negative I, which is negative xi. And then finally, I've got this bracket times this bracket. Now we've already done these before. It's negative times negative, so it's going to be positive. We know that it's 2 times 2, which is 4. And we know that it's I times I, but it's plus I times negative I giving me negative I. And negative I squared, negative I squared is 1, so I'm going to add on 1 here. And 2 times negative 2i, and I times 2, they're going to cancel out. And what's more, and I understand why I'm making my mistake here, is this is plus 2i, and this is negative xi. They're going to cancel out. And it's going to leave me with no imaginary part. So the actual quadratic equation that we started with is x squared minus 2x, and 4 and 1 is written like that. And if I go back, that's exactly the same equation that we started with and drew. So we can find quadratic roots. One root is this, the other root is called the conjugate, and I use a little star to show that. And we can put the roots into factor form, and we can expand it to get back to where we started.